In this lesson, we will use our particle simulation attributes to copy our explosion pyrosim onto our particle sim. First off, I'm just going to turn off the launch smoke for now, since we're not working on that. I'm going to put down a new geometry object, and we'll call it explosion anim. Let's dive inside. Again, we need two object merges. One for our pops points. Let's go to pops launch points, pops points. Call this pops points. And one for our explosion simulation. Explosion into this object. Explosion out, out, accept. So let's go ahead and just drop down our copy SOP. Let's see what we're starting off with. And as you might expect, the explosions are sticking to the points and they're all birthing at the same time. So let's go ahead and get these birthing when the first hit attribute gets set. If you remember, we made that first hit attribute that knows when the point first hits the ground plane. Let's go ahead and map that so we can actually access it. So attribute first hit. Let's go ahead and just name this, rename this SOP so I know what it's doing. AC map first hit. Local variable will be first hit. It is an integer and we do not want to write the values. Now let's go over to our copy, stamp inputs. We use that same variable name bframe that we used in the last lesson, but this time we'll set it to first hit. Go ahead and put down a time shift, and we'll tell this time shift the $F minus stamp, get our copy SOP, the bframe attribute, and default to 0 if I can't find it. And now you see our explosions are birthing at the right time. Now to make this a little bit cleaner, we don't really need these points when the explosions are not yet occurring. So I'm just going to drop down delete SOP to get rid of those, except when they're hitting the ground plane. If you remember, in the pop simulation, our points start off as black, but when they contact the ground plane, it changes the color to red. So we can use that information to delete these points. Change the entity of the points, and use the expression $CR is greater than 0. Now this is going to actually delete the points when they hit the ground, so we do delete non-selected. We should only get points when they hit the ground plane. And if you look here, we're getting that correct functionality. I'm going to step out real quick and just visualize the ground planes. It's a little bit easier to see. And you'll see that our explosions aren't that interesting because they're all pretty much facing the same direction, have the same orientation, and it'd be useful to vary this up a bit. And we can do this with the copy stamp. Let's go up here and let's make a few more variables. We're going to make an R scale for a random scale, and we're also going to add some random rotations. So we'll do rrot X, rrot Y, and rrot Z. Now to do this, we need an attribute that stays constant throughout the entire simulation for our particle simulation, but is unique to each point. And fortunately, whenever we do a pop simulation, it should give you this ID attribute every time. There's a checkbox that's automatically checked on, so if you don't have that ID attribute, maybe that checkbox got unchecked. But unless you mess with the defaults, this ID attribute should be there. And it should be unique for that point and stay like that the entire time. So since we have that attribute, let's go ahead and use a fit function based on a random value of that ID to drive how we're going to construct these stamp variables. So I'm doing fit ran $ID, give us a little bit more room here. Now whenever you do rand will always set your value between 0 and 1. So when you're doing a fit on rand, you always want it to do 0 to 1. And we want to take that 0 to 1 fit and fit it to something maybe like 0.75 to 2. So either the explosion will be a little bit smaller, about twice as big as the initial pyro simulation. Now we want to do something similar for the rotation. I'm just going to copy paste this. Again, we want 0 to 1. However, if the rand $ID is always going to return the same value. The one way we can vary this up or kind of get a different seed is if we take this $ID and just multiply it by some arbitrary number. As long as this is always multiplied by a different number, you won't get the same seed for each rand that you're doing. So something useful to keep in mind. Now since we're doing rotation, rather than doing 0.75 to 2, we'll want something like 0 to 360. So either it doesn't rotate at all or it's fully rotated. Let's do the same for y and z, but again we want to vary up our seed. So I'll just change the value that's being multiplied by $ID. So now we've got this set up properly. To access those, let's use a transform. Let's first go to the rotation and get our stampable values. So for x, we'll want r rot x, and it doesn't find anything, tell it to be 0. I'm just going to copy paste that, tab, change this to y, tab, paste, change that to z. And I'm going to close this real quick, and as you can see, we're getting a random rotation now properly on our explosions. We also made that random scale, so in uniform scale, I'll go in here. I still have that on my clipboard. I'll change that to R scale. And now we're getting differently scaled explosions. And this looks much more interesting than the very uniform explosions we had earlier. So that should take care of all the copying we need to do for those pyro simulations we did earlier. Let's step back out here. Let's display these all, see what these all look like together. And just to make it a little bit easier to know where all this is happening, I'm just going to stick these in a quick net box and make it purple. And just say sim copying, so I know what's going on here. If I hit play, see our smoke coming out of our rocket tubes. We can see our fire trailing our rockets. And then when the rockets hit the ground, we have nice little explosions. So this is all working properly. So that's how we get our explosion sims and all our other pyro sims to occur at the proper time. In the next lesson, we will start constructing our volume trail.